Hello, Lucas Millhaupt provides products and services for brazing metal assemblies. We often speak of the importance of capillary action in the brazing process. This action draws molten alloy into the joint between two metal parts. But what exactly is capillary action? How does it work? And what factors inhibit its action? Today we'll focus on the scientific phenomenon of capillary action. Capillarity is the ability of a liquid to flow in narrow spaces without the assistance of, and in opposition to, external forces like gravity. Let's conduct an experiment depicting successful capillary action. We have two glass plates with shims of equal size, 1 1/2 thousandths of an inch inserted at the top and bottom. This gives us an ideal spacing for capillary action to occur. Now let's see what happens when we dip the bottom into a tray of liquid. As you can see, the liquid is drawn up smoothly by capillarity to fill the entire clearance between the plates. This illustrates the value of a close and uniform clearance for successful capillarity during brazing. Next, we'll demonstrate what will happen when we don't have a proper uniform clearance. These plates are separated by a 1 1/2 thousandths of an inch shim at the bottom and a thicker shim of 15 thousandths at the top. Now, when we insert the plates into the tray, we see the liquid can only rise part way. Capillary action will draw the liquid only to the point where the clearance is 5 to 6 thousandths of an inch. Then the gap becomes too large and capillarity cannot take place. Remember, in our first demonstration, the liquid filled the gap between the plates completely because the space was uniform, so capillarity could operate. For our next experiment, we have glass plates separated by shims representing an ideal uniform clearance of 1 1/2 thousandths of an inch. But inside, the surfaces of the glass have been marked with greasy fingerprints. When we insert these plates into the tray, the liquid rises to fill the gap. However, it leaves voids where the oily surfaces interfere with capillarity. If this were a braze joint, it would not be a sound one. From these illustrations, we can understand several principles relating to capillarity and brazing. First, joint gaps must be of correct uniform size for capillary action to occur. Variation in spacing will affect the success of your brazing operation because capillarity will be compromised. Second, cleanliness counts in brazing. Parts that are not properly cleaned may carry grease or other debris, which will impede the process of capillarity. Successful capillary action, the process that allows alloys to flow into the joint between two metal parts, is crucial to successful brazing. For more information, please visit our website or contact your Lucas Millhaupt representative. Thank you.